Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about XS3 code and conversion of XS3 code to decimal and decimal to XS3 code. Before we start our actual conversion, we should know decimal number and equivalent binary number in a group of 4 binary bit. When we use 4 binary bit, then we know that we always follow 8421 system. So 8421 is very important. For example, if we consider 6 decimal number and if we go for equivalent binary number, then as per the weighted position where we have 1, we can take either 8, 4, 2 or 1. For example, 6. So that is 0 plus 4 plus 2 plus 0. So 4 plus 2, that is 6. So 8421 system should be very much clear, and highest possible number with 4 bit, that is equivalent decimal number is 15. So 8421 system should be very much clear, then we can do the conversion very fast and properly. Now let us understand XS3 code. XS3 code is slightly modified form of BCD code. Actually, it is very similar to BCD code. In previous lecture, we have seen a BCD code, but XS3 is again one different type of binary code, and it is slightly modified form of BCD code. It is non-weighted, reflective as well as sequential code. Now let us see steps to convert any decimal number into XS3 code. So we have step number 1. Each single decimal number is added with decimal number 3 because the name is XS3. So we have to give additional 3 to each decimal number. So each single decimal number is added with 3. Then we have second step. After addition, each decimal number is converted into equivalent BCD number of 4 bit. Right? 4 bit is important. We have to convert into a group of 4 binary bit. Follow 8421 system, that is very obvious. Now let us start converting decimal number into XS3 code. But before that, we should know that highest valid possible number with 4 bit in case of XS3, that is 1100, and that decimal equivalent is 12. Because when we take number 9, single digit decimal number 9, and then we add 3, then it becomes 12. So in normal BCD number 12 may not be possible, but in XS3 12 is the highest possible and valid number. And same way, we have lowest valid possible number with 4 bit is 0011, and that is equivalent to decimal equivalent to 3. Because when we take decimal number 0, then also we add 3. So the minimum decimal number valid possible, that is 3. On most significant side, zeros cannot be eliminated, right? In BCD code as well as in XS3 code, the group of 4 is important. So zeros cannot be eliminated while writing final answer. Now let us convert decimal number into XS3. Suppose we take any number and that number is 409. So first we write individual each decimal number. So we have written 4, 0 and 9. Now in second step, we have to add decimal number 3 in each individual decimal number. So we add 3, 3 and 3. So answer, now 4 plus 3, we know that it is 7, 0 plus 3, then it is 3, 9 plus 3, then 12. So in excess 3, 12 is possible. For 12, we can directly convert it into BCD number, right? In normal BCD number, this conversion is not allowed. Now, second step is very simple. We have to convert each decimal number into equivalent binary number in a group of 4 bit. So 12, we know that it is 1100. For 3, we know that it is 0011. 7, we know that it is 0111. So this conversion is over. We can directly write the answer. For 409 decimal number, we have equivalent excess 3 number, that is 0111 0011 1100. Let us take one more example, then the conversion process will be very simple and it will be properly understood. Suppose we take any decimal number, that is 1, 2, 3. So we write 1, 2 and 3. Then we have to add 3, decimal number 3 in each decimal number. So we add 3 with each number. Then 1 plus 3, that is 4, 2 plus 3, that is 5 and 3 plus 3, that is 6. Now next step is very simple. We have to convert each decimal number into equivalent binary number in group of 4. So 6, 0110, 5, 0101 and 4, 0100. So we have an answer. So this way we can convert decimal number into excess 3 code. Now excess 3 code, if given, then it can be also converted into decimal number. So we have to follow certain steps. Prepare group of 4 binary bit starting from the least significant side. Convert each binary group into equivalent decimal number. That decimal number can be in between 3 to 12. Then obviously we have to follow 8421 system. Now this step is very important. At last, subtract 3 from each individual decimal number, because when we had converted any decimal number into excess 3, we added 3 to make it excess 3. But now while converting from excess 3 to decimal, we have to subtract 3 from each individual decimal number. So now let us convert one excess 3 number. One number is given. We have total 8 bit. So we can prepare 2 different groups. First group, that is 0101. Second group, that is 1000. Now we have to convert each into equivalent decimal number. So 0101, so it is 5. Same way 1000, so it is 8. Now next step is very important. We have to subtract 3 individually from each decimal number. So minus 3 on both the decimal number. So we have answer 8 minus 3, that is 5, and 5 minus 3, that is 2. So our answer is 52. That is equivalent decimal number. We take one more example and then it will be very much clear. So we have taken one number and one binary number, and it is given that it is excess 3. Otherwise we never know that it is excess 3 number, right? That is why the meaning of code. So we convert it into 3 groups. First group, that is 1001. Second group, that is 0111 and 0100. We convert each binary group into equivalent decimal number. So 0100, that is 4, 0111, that is 7, 1001, that is 9. Now do not forget the next step. We have to subtract 3 individually from each decimal number. So we have to subtract 3 from each decimal number. And then we have answer. 4 minus 3, 1, 7 minus 3, 4, 9 minus 3, 6. So 1 for 6, it is our answer. So I hope that the conversion process from decimal to excess3 as well as from excess3 to decimal is very properly understood. Thank you for watching my video. Keep watching. Thank you very much.